You can use polyvinyl chloride, or PVC, conduit for running electrical through a concrete sidewalk, provided it is buried at least 18 inches deep. Here are the steps to follow. Firstly, choose the right size conduit. Determine the number and size of wires you will be running, and select PVC conduit that is large enough to accommodate them with ample space for insulation. Secondly, install the conduit form. Cut the conduit to the desired length and install it in a concrete form before pouring the concrete. Use hooks or stakes to secure the conduit in place. Thirdly, seal joints. Apply PVC glue or cement to the ends of the conduit and connect them securely. Use a brush or roller to apply a thick layer of glue along the entire joint. Fourthly, provide access points. Install pull boxes or handheld access points along the conduit run for pulling wires later. Fifthly, cover with concrete. Pour the concrete over the conduit, ensuring that it is completely covered and embedded at least 18 inches deep. Sixthly, protect from damage. Use caution when working around the concrete with heavy equipment or tools to avoid damaging the conduit. Advantages of PVC conduit include being lightweight and easy to install, flexible, making it easier to bend and route around obstacles, corrosion resistant, and relatively inexpensive. If the conduit will be subjected to heavy loads or extreme weather conditions, consider using rigid conduit instead. When selecting the right size conduit, consider the National Electrical Code, or NEC, guidelines for conduit fill. The NEC specifies the maximum percentage of the conduit's cross-sectional area that can be occupied by conductors. This ensures adequate space for heat dissipation and easy wire pulling. Consult NEC Chapter 9, Table 1 for conduit fill limitations. For example, for 3 or more conductors, the maximum fill is typically 40%. To determine the appropriate conduit size, calculate the total cross-sectional area of all conductors, including insulation. Then, select a conduit size with a usable area that exceeds this total, while adhering to the 40% fill limit. Remember to account for future expansion when estimating the number of conductors. It is often prudent to choose a slightly larger conduit size to accommodate additional wires if needed. When installing the conduit form, precise measurements are crucial for ensuring proper alignment and depth. Before cutting the conduit, carefully measure the distance between the electrical source and the desired termination point. Add extra length to each end of the conduit to allow for connections to junction boxes or other enclosures. Use a conduit bender to create smooth, gradual bends in the conduit, avoiding sharp angles that can damage the wires. Secure the conduit in a concrete form using conduit straps or clamps spaced at intervals recommended by the NEC. This prevents the conduit from shifting during the concrete pour. Ensure the conduit is buried at the required depth of at least 18 inches to protect it from physical damage. When sealing joints, proper application of PVC glue or cement is essential for creating a watertight and durable connection. Clean the surfaces of the conduit and fittings with a PVC cleaner to remove any dirt or grease. Apply a generous layer of PVC primer to both surfaces to soften the plastic and promote bonding. Immediately apply PVC cement to both surfaces and quickly join the conduit and fitting, twisting slightly to ensure even distribution of the cement. Hold the joint firmly in place for several seconds until the cement sets. Remove any excess cement with a clean rag. Allow the joint to cure completely according to the manufacturer's instructions before proceeding with the installation. When providing access points, pull boxes or handheld access points are necessary for facilitating wire pulling and future maintenance. Choose access points that are appropriately sized for the number and size of conductors. Install the access points at intervals recommended by the NEC, typically no more than 100 feet apart for straight runs. Ensure the access points are securely mounted and accessible after the concrete is poured. Consider using weatherproof access points if the sidewalk is exposed to the elements. Label the access points clearly to indicate the circuits they serve. When covering with concrete, take precautions to protect the conduit from damage during the concrete pour. Support the conduit adequately to prevent it from sagging or shifting under the weight of the concrete. Use a concrete vibrator to consolidate the concrete around the conduit, eliminating air pockets and ensuring a solid encasement. Avoid dropping heavy objects onto the conduit or walking on it before the concrete is set. Allow the concrete to cure completely according to the manufacturer's instructions before backfilling or applying any loads to the sidewalk. When protecting from damage, be mindful of the location of the conduit when performing any excavation or construction work near the sidewalk. Clearly mark the location of the conduit on site plans and communicate this information to all workers. Use caution when operating heavy equipment or tools around the conduit to avoid accidental damage. If the conduit is exposed during excavation, immediately repair any damage and provide additional protection. Consider installing warning tape or concrete markers above the conduit to alert future workers to its presence. The NEC provides detailed guidelines for the installation of electrical conduit in various environments. Adhere to all applicable NEC requirements to ensure a safe and compliant installation. Consult NEC Article 352 for specific requirements for PVC conduit and Article 344 for rigid metal conduit. Pay close attention to requirements for conduit support, grounding, and bonding. Obtain all necessary permits and inspections before starting any electrical work. Hiring a qualified electrician is recommended if you are not familiar with electrical codes and best practices. When working with electricity, always prioritize safety. De-energize circuits before working on them. Use appropriate personal protective equipment, such as safety glasses and gloves. Follow lockout/tagout procedures to prevent accidental re-energization of circuits. Test circuits with a voltage tester before touching them. Never work alone on electrical projects. Be aware of potential hazards such as overhead power lines and underground utilities. If you are unsure about any aspect of the installation, consult a qualified electrician. In addition to the NEC, local building codes may also have specific requirements for electrical installations. Check with your local building department to ensure compliance with all applicable codes. These codes may address issues such as conduit depth, access point locations, and grounding requirements. Obtain all necessary approvals from the building department before proceeding with the installation. Failure to comply with local building codes can result in fines or delays. When selecting between PVC and rigid conduit, consider the specific requirements of the application. PVC conduit is generally suitable for underground installations where it is protected from physical damage. Rigid conduit, such as galvanized steel conduit, is more durable and resistant to impact. It is often used in applications where the conduit is exposed to heavy loads or potential damage. In some cases, local codes may require the use of rigid conduit for certain applications. When using rigid conduit, be sure to properly ground and bond the conduit system to prevent electrical shock hazards. Use appropriate grounding bushings and bonding jumpers to ensure a continuous ground path. Consult NEC Article 250 for specific requirements for grounding and bonding. Consider the long-term maintenance requirements of the conduit system. PVC conduit is generally maintenance-free, while rigid conduit may require periodic inspection and maintenance to prevent corrosion. Choose a conduit material that is appropriate for the environment and the expected lifespan of the installation. Document the location of the conduit run on site plans for future reference. This will help prevent accidental damage during future excavation or construction work. Include information such as conduit depth, material, and size on the plans. Provide copies of the plans to the property owner and any relevant authorities. Consider using a conduit locator to verify the location of the conduit before digging. A conduit locator is a device that emits a signal that can be detected above ground, allowing you to pinpoint the exact location of the conduit. This can help prevent accidental damage during excavation. If you are working in an area with underground utilities, contact the local utility companies before digging. They will mark the location of their underground lines to prevent damage. Dig carefully around underground utilities to avoid damaging them. Remember that electrical installations can be dangerous if not performed properly. Always prioritize safety and consult with a qualified electrician if you have any questions or concerns. By following these steps and adhering to all applicable codes and regulations, you can ensure a safe and compliant electrical installation.